Hi, friends, and welcome to another What's the Math Wednesday. Last week, I taught you guys an intro to trig so that this week I could teach you how to use trig to solve for missing sides and angles. So, first things first, this entire lesson will be in degrees. So, you would want to make sure that your calculator is in degree mode as well. And if that's something you need help with, just comment like what type of calculator you have, and I will show you or talk you through how to switch it from degree mode or radian mode to degree mode if your calculator is in that mode. So let's go. So when I start teaching trigonometry and geometry, I always say there's 3 questions you want to ask yourself with every problem. And it comes natural by the time you like really delve into trigonometry. And the first question is, am I missing a side or an angle? So that's an easy question. You're either going to have like X on a side or X in an angle. The reason you want to ask that is because there's a difference between normal trig and inverse trig. So inverse trig, you'll see like there'll be a -1 next to the trig function. And you only use inverse trig if you're solving for an angle measure. So if you're solving for a side length that's missing, it would be like regular or normal trig. You would only use inverse trig if you're solving for an angle measure. Now, just to show you, if you're using a calculator at this point, like if you're following along with a calculator, I don't have any TI 83s or anything with me at the moment, but I do have my cell phone. So I have an iPhone. So if you turn your phone horizontal, you'll see the bottom, there we go. The bottom second to last row has sine, cosine, and tangent on the bottom there. Don't use the one with the H, use the one above it. And then if you need inverse trig, you would hit second first. So second is like, it's highlighted now because I hit it. It's right there. Anyway, and then you'll see that second to last row, now you have sine, cosine, and tangent with the -1s. So you only use those if you're solving for missing angle measures, and we'll get there. Here we go. Okay, so that's why that is the first question, because you need to know whether you're using normal trig or inverse trig. The second question I always ask myself is the hypotenuse involved? Now, involved could be it has a numerical value, or involved could be that it has a variable, X, Y, whatever you want to say. Reason this question is important is because if you look at SOHCAHTOA, tangent is the only trig function that does not use the hypotenuse. So if your problem doesn't use the hypotenuse at all, you automatically know that you're using tangent. And that's an easier process, then you know where you're going. If you are using the hypotenuse, then you would want to go to the third question on this, which is what's the relationship with the acute angle and the leg? The purpose of this question is to determine whether you have an opposite relationship or an adjacent relationship so that you can determine whether you're using sine or cosine. So I will talk you through my 3 examples using those questions, and we'll go from there. So here we go. Example number 1. So if you look at this problem, we have an X on a side length, which means I'm missing a side. So I know I would use normal trig in this problem. The question number 2 says, is the hypotenuse involved? The answer is yes, because there is a 6 on the hypotenuse. Side note, again, hypotenuse is the side across or opposite of the right angle. So that's what the 6 is. 3, so we're going to have to use question number 3, because at this point, because we're using the hypotenuse, it could be either sine or cosine. So we have to see what the relationship is with the angle measure, which is 73 degrees, which is our bottom left angle, and the leg, which has the X on it. So if you look, they are adjacent. They are next to each other, which means that we're using cosine. So recapping, we're missing a side length, so we're using normal trig. The hypotenuse is involved because there's a 6 on it. And the relationship between the acute angle, which is the 73-degree angle, and the leg, which has the x on it, is that they're adjacent. So we're using cosine. So when I set up the problem, I do trig function, angle measure. So cosine is our trig function. The angle measure is 73. So cosine of 73 degrees equals, and then we put the ratio. The ratio for cosine is adjacent over hypotenuse. So the adjacent leg is x, the hypotenuse is 6, so it's x over 6. So the initial setup, trig function, angle measure equals fraction. Okay. Then from there, you want to isolate your x. So since the 6 is on the bottom in the fraction, what we could do is multiply both sides with 6. It'll cancel out the 6 that's with the x, and it'll move it over to where the cosine is. So 6 times a cosine of 73 will equal x. If you're using a graphing calculator, you can put that directly in as you see it, 6. Then you'd press the cosine button, you'd type in 73, and it would give you approximately 1.8. If you're using a cell phone to do this problem, you'd have to type in the 73 first, then you would hit the cosine button, and then you'd multiply by 6. So it's a little backwards if you're using a cell phone calculator. And I would imagine that if you're taking like a test in school or something, you can't use your cell phone, so you'd use a graphing calculator. So that would be easy. You would just do 6 times cosine 73. Typically, when you do these problems, you round side lengths to the 10th, which is 1 decimal. So you would look at the second decimal and then judge from there whether you're keeping the number, that first decimal value, or if you're rounding up. So, just remember, like 5 and above, you round up, 4 and below, you keep as is. Okay. Example number 2. So looking at this problem, I see that a side has an x, which means I am missing a side. So we're using normal trig again. Number 2 says, is the hypotenuse involved? If you look, it is not. There is no value or variable on the hypotenuse, so I automatically know I'm using tangent. So I don't have to go into that third question. So here we go. Tangent with this problem. Tangent, angle measure. So trig function, angle measure. So tangent, the angle measure is 49, equals the ratio, the fraction. So tangent is opposite over adjacent. So the opposite side to the 49 is the 14. The adjacent side to the 49 is the x. So tangent of 49 degrees equals 14 over x. So like we did last time, we want to isolate our variable. So first thing I do is I multiply both sides by x. It'll cancel it out where the 14 is, but it brings it over to where the tangent of 49 is. So at that point, x is still with something and we want it by itself. So we would divide both sides by the tangent of 49. That way it cancels that out on the left side and brings it over to the right side. And then x is by itself on the left side. So x is equal to 14 divided by the tangent of 49, which when you plug that into a calculator, you get approximately 12.2. Okay, so things to notice from these last 2 examples. If your unknown or your x is on the top of the fraction, all you have to do is bring the bottom of that fraction value over to the left side. If your unknown is on the bottom of the fraction, like in this case, you literally would switch the trig function with the angle measure and x. So in this case, like the tangent of 49 switched places in the original setup with the x. And that will happen, sorry guys, that was my phone. That will happen for any example, any trig example where you're solving for a side and x is on the bottom of the fraction. Let me just do a quick shout out to CUDA software. All of these examples and the UDO problems are from CUDA software today. So thank you to CUDA software for always giving me practice problems and examples to go through with you guys. I love CUDA software. It's a great worksheet. It's a great website. So if you are looking for extra practice, that's always a great place to go. Okay, here is my last example for you guys. So looking at this problem, am I missing a side or an angle? If you look, two sides have values and there's a question mark inside of the triangle at an angle measure. So I'm missing an angle measure, which means I'm using inverse trig. Is the hypotenuse involved? Yes, it is. There's a 42 on it. So what's the relationship with the acute angle and the leg? So the question mark is our acute angle. The leg is the 40 length. So they are opposites. So I'm going to use sine, and specifically I'm going to use inverse sine with this problem. Now, when you're doing inverse trig, it's much easier. So you would do inverse trig function and then the fraction. So in this case, inverse trig function would be sine with the -1. And the fraction is the opposite over the hypotenuse. So inverse trig of 40 over 42, that would equal our angle measure. And typically with angle measures, they want you to round to the nearest whole number or nearest degree, which is the same thing. So this is approximately 72 degrees. Now again, guys, you have to use the inverse button, like the inverse trig button. So if you're using a graphing calculator, there'll be like the second button, like it has like the 2 with ND. You'll hit that first and then you'll hit your trig function. Because typically on a graphing calculator, like right above sine in a different color is inverse sine. So you'd hit second and then you'd hit sine and then the inverse sine would come. So if you guys have any questions about these problems, please let me know, comment, and I will try to get back to you as soon as I can. So here are the 3 you-dos. Don't forget, I will put a link for the answers where I explain how to do them. So here's your first you-do. And I'd like you to round this answer to the nearest whole number, and you're solving for x. And if you're looking at just the values, just for clarifying, maybe this is blurry for you. The bottom is 38 and the right side is 27. So those are the values in this problem. And then there's an x inside. Okay, you do number 2. There is a 29, there is a 19. The symbol with that is degrees, and there is an x. So for this problem, I'd like you to round the answer to the 10th, which again is 1 decimal. And last but certainly not least, you do number 3. You have a 72-degree angle, you have an x, and you have a 6. So good luck, guys. Again, if you need any help, additional help, please comment. Or if you'd like another topic shown, comment that as well. You can always reach out to me. If you're watching this on YouTube, my Instagram is Manny's. Wow. That's what happens, guys, when you go into a whole big math thing. Then you're like, what's my name? What's my account? That's a great thing to have happen just now. It's Manny's _music _nerdy _things. I'll try to tag it in my YouTube. Or if you're on Facebook, I'll try to tag it there too. All right, guys. Have a great day. Bye.